Guys, today we are going to discuss an important topic in a security. Okay, so this is an IPsec where it will provide an security for the layer 3. Okay, in the name itself, we can see IPsec, which is an Internet Protocol security. So we don't have any security for our L3 traffic, right? Whatever the traffic going in the network layer, we don't have. Whatever we see that will be going to the internet, we don't have any security. So in order to provide secure communication through the internet or secure communication between site to site, okay, they came up with an IPsec, which is an internet protocol security. So what are the agenda of this class? Means we need to know about what is security and what is internet key exchange and what are the phases in that internet key exchange. Okay, and also IPsec modes and IPsec protocols. Okay, as I discussed before, IPsec is a framework, okay, that helps to protect the IP traffic on the network layer. See here, whatever the traffic, whatever the our L3 traffic, right? These are the network layer traffic. Whenever you are whenever you want to send your information, right? Let's suppose take any one of the organization. Okay, let's take we have an organization called XYZ. They have an branches in one branch in Bangalore, another branch in Hyderabad. So they want to exchange the information, okay, for whatever the users that are in the Bangalore branch, and they want to send some information, some sensitive information to the other branch. Okay, so in order to if you want to send this sensitive information means that should not be that should not be visible to the other people who are there in the internet, and also that should not be tampered. Okay, so in order to send this sensitive information securely, we need to build an IPsec between these sites. Okay, uh, Bangalore site, and between the Bangalore and Hyderabad site, we have to build the IPsec, okay, which we call as an IPsec tunnel or site to site VPN. Okay, so we need to build an IPsec tunnel so that our sensitive information will flow through this IPsec tunnel, so that no one can be visible. Okay, no one can see this information, or even though they can see, they won't be able to see the what exact information in that. Okay, so in order to achieve that, this IPsec will be featuring will be having some features. The first one is an confidentiality. Okay, confidentiality means whatever the traffic, okay, whatever the message or whatever the information that we are sending from our Bangalore site to Hyderabad site, what the IPsec will do is the IPsec will be encrypting the data. Okay, encrypting means it will be converting our plain text. Okay, our whatever the information that is in the plain text, that should be converted to the some cryptographic form, so that nobody in the internet can able to read that. Okay, only the sender and the receiver. Okay, sender means who are sending this information, and receiver means who are receiving the information. Only they can be able to see that information, and nobody in the internet or nobody in the public can't see that. Okay, or can't read that data or can't read that information inside. Okay, and second one is an integrity. Okay, integrity means this integrity will be achieved by hashing the information. Okay, hashing the information means it is same like encrypting, but it is calculating some values. Okay, whenever we are sending an data from sender, okay, it will be calculating the hashing value, and it will send to the receiver. Receiver will receive this information, and it will also calculate the some hashing value. Okay, and if this hashing values matches, it will be get conclude that no whatever the information that we have sent, and whatever the information that are received or same. Okay, so by hashing, what we can achieve means if you are hashing this information, nobody in the internet can't modify the can't modify the message or information that is sending over the internet. Okay. And authentication, before sending the information, both parties instance, both the sender and the receiver need to be authenticate in order to make sure that we are getting an data from the uh, exact or legitimate sender and the receiver. Okay, both sender and the receiver will be authenticate each other, so that it will know that they are getting the data from right resources. Okay. And anti-replay, how anti-replay will work is, even the packet is encrypted and authenticated, some of the attackers will be there in the internet. They are using some advanced tools, and they are trying to steal your data. Okay. Whenever there is change, this whatever the information that we are sending, there will be have some sequence numbers. Okay. Whenever the information is changed, or whenever data that is sending from the sender and the receiver, whenever the data is changed, the sequence number will get changed. Okay. Whatever the sequence number that we are sending here, the same sequence number that should be on the receiver end as well. If anything modified, the sequence number will get changed. And this whenever the changed packet will send to the whenever this changed packet receives the receiver, it will check the sequence number. If the sequence number is not matching, the receiver will be thinking that it is getting some duplicated packets, or that data is modified in that packet, and it will be considering as a duplicate packet, and it will discard. Okay. So this is how this IPsec will be used, and IPsec will be created between site to sites in order to provide the data in a secure manner. Okay. How it will secure the data means all these three things. Okay. It will use confidentiality by encrypting the data, and it will use integrity by hashing. Okay, by calculating hashing values, and authentication in order to make sure the data is receiving and sending from the right resources. And anti-replay, it will be using sequence number to exactly know whether it is an duplicated packet or not. Okay. These are the some features that IPsec will be providing, and we will see more about these features in the next. Okay. These are some IPsec protocols. Okay. How IPsec protocols, in the sense, what are the protocols that we are using in the IPsec? And encryption methods, authentication. This is not exactly the authentication, we can call it as in hashing. Authentication methods are different. We have two authentication supported in the IPsec. Okay. One is an pre-shared key, where we can manually configuring this pre-shared key, like how we can configure an passwords. Okay. How we can configure passwords, just like some numbers, letters, and some special characters, right? Pre-shared key will also be manually configured in the same way, so that it will be easy for us to maintain. Okay. Whatever the pre-shared key that we are configuring here on the one from one side, and it will be matching to the other side as well. The pre-shared key should match. Okay. And apart from the pre-shared key, there is another method called the IPsec will use a certificate. Okay. Certificate for the authentication. We have to use the same certificate on the both sides. Whether you can generate the certificate on the firewall, or you can get the certificate from any of the third party. Okay. So we can install this, import this certificate in the firewall, and we can use this certificate for authentication purpose in the IPsec. Okay. So these are the two authentication methods in the IPsec. One is an pre-shared key, and other one is an certification. Okay. And DeFi element group, this is also one of the group where it can provide the strong hashing values. Okay. Higher the group number, more will be an security. Okay. If here we can see DH1, DH2, DH5. Okay. So we'll be having the whenever you can see the more DH value, it will be having an more security. Okay. So instead of going with DH1, you can go with DH5, but we have now we have up to DH group 20, so we can use group 20, so that it will be more protected. Okay. So these are the some listed methods and protocols that in the IPsec. Okay. And types of VPNs. Okay. we have the two types of VPNs in the security. Okay, one is an site to site VPN, where you are creating an IPsec VPN between routers and routers, or firewalls and firewalls. Okay, if you are configuring, whether we can call it as an site to site as well. Okay, one firewall is in or one router is in one branch, and other router or other firewall is in another branch. So we are forming an IPsec tunnel between the firewall and the firewall, and router and the router. Okay, you can also configure an IPsec in the routers as well, but mostly the IPsec will be used in the firewalls only. Okay, and one more thing, one other VPN is an remote access VPNs, where it will be forming an VPN between our firewall and the Windows machines. Okay, with not only Windows machines, whatever the local machines that you are using, whether it is an Windows, whether it is a Mac or Linux, Android. Okay, Android phones, iOS phones, we can all devices. Okay, all networking device will support these remote access VPNs, but you have to install some software to get connected to your office network. So those softwares will, if those softwares are connected, so it will be providing your secure channel between your local device to the firewall, so that whatever the traffic that is going through your local device, it will be flowing through the tunnel. Okay, this is a remote access VPNs. And do you have any questions or any queries before proceeding? Any queries or any clarifications on these features or types of VPNs?
Yeah, I have a question here.
Yeah,
Can you go back, like you shown like integrity authentication table, right?
yeah, yeah, yeah.
Yeah, the, over there, I mean, we can use DH1, DH2 until it will be like DH20, right?
Yes.
Because most of the times, what we will use, which group we will
Most of
use?
the times we will use the group 20, because the higher the number, I told you, right, the higher the number, it will be providing a more security, and it will also calculating the more hashing value, so that it will be difficult for others to whatever the data that we are sending, they to modify. Okay, so higher the group, higher more the security.
Okay, so in the real life scenario also, if you are doing something IPsec tunnels means we have to use DH20 group, or
Yes, yes,
as
that's
per
correct.
the client requirement, they will tell us like we have to use only this group.
No, if the client requirement is something else, that you can follow with the client requirement. Otherwise, you can go with the more higher group number. Okay.
Okay, got it. Thank you.
Yeah. Yeah. And we are proceeding further. Okay. We are proceeding with the IKE phases. Okay. We need to know what is IKE first. Okay. IKE is an internet key exchange, where it is an protocol where, in the IPsec. This IKE is using an UDP port. Okay, IKE will use an UDP port with the port number 500 to establish an IPsec tunnel between our sites. Okay, so in this IKE we have in two phases, phase 1 and phase 2. Okay, what is why we are using both phases means, this phase 1 will mostly use to form a tunnel, and after forming a tunnel, it will mainly using for the management traffic, as well as it needs to be send the phase 2 traffic. Okay, once the phase 1 tunnel is up, then only you can be forming an phase 2 tunnel. Until unless phase 1 is not found, phase 2 will won't form. Okay, in the initial step. Okay, whenever you are configuring IPsec initially on your firewalls, so the phase 1 has to be formed first, so all the management traffic and phase 2 traffic will be flown through the phase 1. And after phase 2, after phase 1 is forming, our phase 2 parameters or phase 2 traffic will be flown through the phase 1, right? So after successfully exchanging of these phase 2 parameters, the phase 2 tunnel will also form. And after phase 1 and phase 2, our exact data will be flown through the phase 2. Okay, how it will be like, I'll show you. See here, for suppose I have an firewall, okay, on one branch, and this is other firewall on another branch. We are having an connection, okay. I am directly connecting, but they should be connection like this or in different locations, right? The connection should be not be and directly connected. It will be going via internet. Some ISPs are connected, okay. The connection should be like that. And we are forming an IPsec tunnel, okay. We are forming an IPsec tunnel between these two firewalls. So once, whenever we are forming an IPsec tunnel, first it should have build the phase one tunnel, okay. We have to build the phase
Karthik,
one tunnel. Sorry.
one query, sir. The VPN, like site to site VPN is there. One is a remote access is also a VPN.
Yes, remote access also VPN on. Hello, can you hear me, right?
Yes.
Yeah, remote access is also a VPN, okay. We are forming an tunnel between our or VPN between our local machines and the firewall, okay. That is a different VPN. There we are using some SSL VPNs, okay. But here between site to site we are using an IPsec VPN, okay.
So, sir, the difference technically between, because I've heard in interview they asked like what is difference between a remote access VPN and a site to site VPN.
Yeah, site to site VPNs mostly we are forming between the sites, okay. Firewalls and routers and the routers, okay. But remote access VPNs will be mainly formed between our local devices, or local devices in sense our Windows machines or Linux machines or Mac OS machines to the firewalls or routers.
Okay.
We have an global protect, okay. We have another topic called global protect, where we are using that as a remote access VPN. You can know more about that, okay. No worries. Yeah. See here in our IPsec, we have to form the phase one first, okay. We have, there are some parameter needs to be exchanged that I will discuss in next one, okay. So I'm just giving a brief overview. First, we need to form an phase one tunnel, so that it will be using for the management traffic and all the phase two information, okay. When the phase one is tunnel forms, all the phase two information will be flown. And once the this will also phase two also having some parameters needs to be exchanged between sender and the receiver. So after successful matching all the parameters, the phase two will be formed, okay. After phase two will be formed, then only our actual traffic, okay. Actual traffic in the sense whatever the information that we are sending, that will be flown inside the phase 2, okay. Let's suppose, let's take this is an phase 2, okay. Our actual traffic will be flown inside the phase 2, okay. Here the actual traffic will be flown inside the phase 2, okay. So we'll be having phase 1 for management traffic, and in order to send the phase 2 traffic, and the phase 2 will be formed so that our actual traffic flown through the phase 2, okay. So if we want to build up phase 1 tunnel, what are the things that we need to do, okay. So here in the IKE phase 1 we have two modes, okay. One is an main mode, and second one is an aggressive mode, okay. We have two modes. Why we have two modes, and what is the which mode we can use in the site to site, you will know more about this, okay. So in the main mode, what it will do, okay, whenever you are forming an phase 1 tunnel using a main mode, what it will do means, for now I'm not going with an aggressive mode, I'm going the main mode. In the main mode, what it will do is the sender and the receiver, okay. Let's suppose this is an our sender, okay. Sender, our, this is in our firewall which is in an Bangalore, okay. Whatever the information that it is receiving, we can call it as receiver, which is an Hyderabad site. Okay, in the main mode there will be an 6 messages. Okay, the 6 messages will be exchanged between the sender and the receiver. Okay, in the first message, what it will exchange, okay, in the first message it will be exchanging the parameters. We can call it as an security association parameters. Okay, there are certain parameter needs to be exchanged, need to be exchanged between sender and the receiver to form an phase one. So those parameters we can call it as an security association parameters. What it includes, okay, what it includes in the security association parameters means hashing, okay, authentication, whatever the things that we have discussed. Okay, whatever the things that we have discussed before, the features in the IPsec, those are the things that we need to exchange here. Okay, hashing, authentication, group, lifetime, and encryption. Okay, these are the 5 parameters that needs to be exchanged between sender and the receiver. And for my easy understanding, okay, for my easy understanding, I have made it as an haggle parameters. Okay, haggle means H means hashing, A means authentication, G means group, L means lifetime, E means authentication. I am calling it as an haggle parameters to easily remember, so that we can easily remember what are the parameters that are exchanging in phase one. Means we can easily remember with an haggle. Okay, haggle means H means hashing, A authentication, G group, L lifetime, E encryption. Okay, so these are the parameters exchanging in the first message from sender to the receiver. And in the second message, the same parameters. Okay, in the second message, the same parameters, same haggle parameters. In the IPsec terminology, we can calling it as a security association parameters or SA parameters. And for my easily understanding or easily remembering, I am using as an haggle parameters. So it will also sending same thing. Okay, it is sending hashing hashing algorithm and authentication, group, lifetime, and encryption. Okay, whatever the parameters that both are exchanging, all the parameters should match. Okay, if you are using we have an uh, in the hashing we have an md5 and sha. Okay, these are the two hashing parameters. Okay, if you are using md5 here, okay, if you are using md5 in the one side, you have to use the same md5 here as well. Okay, this is these parameters is in our hands. Whatever the we need to configure first, right? We need to use same parameters on both sides. Okay, if parameters or if any of the parameters are not matching, the phase one will not come up. Okay, this is also one troubleshooting scenario where you can experience while doing a lab. Okay, whenever you are seeing phase one is not coming up, there should be any mismatch of this 5 parameters. Okay, maybe you have configured md5 here and other side you have configured sha. Okay, whether and in the other in one side you have configured pre-shade key. You have configured pre-shade key only, but you have missed some letters or some characters in the pre-shade key. I told you, right, the pre-shade key is of like how you can create a passwords. You can create a passwords using some characters, letters, numbers, right, numeric. Okay, so maybe you have using the same pre-shade key, but you have missed some characters in the pre-shade key. Okay, so there may be chance of we are the humans, right? There may be some human error, so there may be a chance of mismatching a pre-shade key. So in that case also, you will be not forming an IPsec phase one. Okay, so if IPsec phase one is not coming up, maybe first thing you need to check is an parameters. If any of the parameters are mismatching, or if any of the parameters are not matching with other, the phase one will won't come up. Okay, so this is a important thing. And in the third message, whatever the group that we are discussing here, the actual key exchange. Okay, key exchange means the DH key exchange will be happen here from sender to the receiver. And in the fourth message also, it is also sending an same DH key. Okay, same DH key will be exchanged between the sender and the receiver. Okay, and in the fifth message, it will be sending an authentication parameters. Okay, so not authentication, it is for the identification. Okay, identification in sense, in the identification we are sending some user credentials. Okay, user credentials or some private some sensitive information private IP of your system for identification of our whoever it is sending. There will be sending some identifications like user credentials and private IP. So we are sending these are the sensitive information, right? So that's in the main mode. What it will do is this sensitive information will be in the encrypted format. Okay, in the encrypted format we can't see what are the information that is sending in the identification or in the fifth message. So maybe mostly it will be sending some sensitive information like user credentials or private IP, but we can't see our with our naked eyes. So why means it will, the fifth message is encrypted, and also the sixth message is the same. Okay, sixth message it will also sending for, it is also using for identification, and also sending its you own user credentials or any private IPs. Okay, private IPs or private subnets, and this is also encrypted format. Okay, we can't see what the information will available in the whenever you are taking packet capture. The in the phase one you can see the fifth and sixth messages are encrypted because these are the some sensitive information which is flowing from one side to other side, which needs to be encrypted or which needs to be not exposed to the internet. So that's why in the IPsec main mode the fifth and sixth messages are encrypted. Okay, these are the six messages that are going to exchange between sender and the receiver. And if you go with the aggressive mode, okay, in the aggressive mode we'll be having only the three messages. Okay, we'll be having three messages. What it will do in the aggressive mode means in the first message itself it will be sending all the information whatever we are sending here. Okay, in the first message it will send the haggle parameters and also key exchange. Okay, key exchange, and it will also sending an identification. Okay, and in the second message, the first message is from the sender to the receiver. Okay, sender to the receiver, and here also the haggle parameters should match on both sides. Okay, in the second message it will be sending the same haggle parameter, key exchange, and also the identification. Okay, here and identification, after that it will be sending some acknowledgement of the first message, and in the third message it will just having some acknowledgement for the second message. Okay, it will be having some acknowledgement. So these are the three messages that are going to exchange the aggressive mode. But what are the main difference between main mode and aggressive mode, and what will be where we can use main mode and where we can use aggressive mode? Okay, so if you see here the things that the main difference between this main mode aggressive mode, we can see here itself. It will be having, the main mode will be having six messages, but aggressive mode will be having three messages. Okay, and the aggressive mode, the main mode will be the slow process. Okay, slow process in the sense it will be has to process all the six messages one by one, right? So it will take some time and it will be considering as a slow process. But aggressive mode is a fast process because all the information will be sending in one message, so it will be processed very quick when compared to the main mode. Okay, and the next main thing is an main mode is an secure method. Okay, secure method in sense our fifth and sixth messages, whatever the identification that we are sending is an encrypted one. Okay, so that's why main mode is an secure method or secure mode. but aggressive mode is not an secure one. Okay, whatever the identification that we are sending in plain text, so that any one of the user or any one of the hacker sitting in the internet, they will easily be able to check what are our identification, what are our user credentials, or what are our private subnets that we are sending between one side to other side. Okay, so aggressive mode is not an secure method, but main mode is secure method because of fifth and sixth methods are encrypted. Okay, so that's why the main mode will mainly used between the site to site. Okay, main mode whenever you are doing IPsec. Okay, IPsec, you are whenever you are forming phase 1 in the IPsec, the these sites will mostly go with the main mode because of the fifth and sixth messages are encrypted. But when we use an aggressive mode, okay, aggressive mode where you have no concern of the security, but you have to form an IPsec tunnel fast. Okay, in that case we can use aggressive mode. In which case we can use aggressive mode means aggressive mode will be used in the mostly in the remote access VPNs. Okay, in the remote access VPNs we need to connect fast to have access our company resources, right? So in that case we can use in the remote access VPNs we can use aggressive mode. But the main mode, the site to site VPNs, whatever the IPsec forming between one between firewall and router, the router, or forming once between one site and other site, it will be go with the main mode. I will show you when we are doing an configuration, or whenever we are doing lab. I will take the packet capture, so I will show you which mode it will. We are not configuring anything here. Okay, we are not configuring anything here. So what by default what mode it will select. Okay, if you are using IPsec between site to site, it will obviously go with the main mode because of the fifth and sixth messages are encrypted. Okay, these are the two modes that are in the IPsec phase 1. So in next thing is an IPsec phase IKE phase 2. Okay, in the IKE phase 2 we have only one mode, which is an quick mode. All it will also have some three messages that needs to be exchanged. Okay, the quick mode also three messages needs to exchange between sender and the receiver, but all the three messages are encrypted. Okay, can you guess the reason why all the three messages are encrypted? In the phase 2 we have the quick mode. In the quick mode also will uh, the sender and the receiver will be exchanging three messages, but all the three messages are encrypted. Whatever it is exchanging between sender and the receiver in the quick mode, we can't see anything. Okay, all the three messages are encrypted. Do you know the reason why we are seeing encrypted packets here in the quick mode? Any guess?
Sorry, come again.
Yeah, I told you, right? We have in the phase 2 we'll be having quick mode, right? In the quick mode there are three messages that are exchanged between sender and the receiver. All the three messages are in encrypted format. We can't see what are the information that is exchanging between between sender and the receiver. Do you know the reason why we are seeing the packets are in the encrypted format? Or do any guess why we are seeing encrypted packets in the quick mode?
So we are sending the data, right? And the data which is we are sending, it should be encrypted. I mean, no other. I mean, like if someone want to hack the firewall, they don't want to see. So that's the reason we are encrypting.
Yeah, that is a 50% correct, but how why we are seeing, okay, why we are seeing that encrypted? In the before itself I told you whatever the phase 2 information is flowing from central and receiver, it will be flown through the phase 1, right? So we have already formed an phase 1 tunnel, which is the secure channel for the phase 2. Okay, so the all the information of the phase 2 will be forming through the phase 1. So already we form a phase 1, right? So that's the reason we are seeing the all the messages in the phase 2 of quick mode is an encrypted format, okay, because we have already formed a phase one tunnel which is an secure channel for phase 2, okay. That is the reason
Okay.
we are seeing the encrypted, all the messages are
Okay.
encrypted.
So, for example, if we are creating phase one means for sure we have to create phase two as well, or we have to stop only phase one only from the sender to receiver.
Sorry, can you come again?
You said like we are doing IPsec tunnel from remote sites, right? From one
Yes,
branch to other branch. If we are
yes.
creating phase one,
Hmm.
so is that mandatory to create the phase two as well, or only we can do phase one and we can stop it and we will go to the next step?
No, 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 no. You have to form both phases, okay.
Okay, yeah.
The phase one, we are forming a phase one, two is a secure channel for phase two, and we are building a phase two to send in our actual data through the phase two. The actual data will be flown through the phase two only. Until unless you form the phase two, our actual data will not flow through the between site to site, or will not exchange any actual information from sender and the receiver. We need to form both
Okay,
phases.
okay. For the phase one, it will send it, and for the phase two, it will receive it, right? That is the one you are saying,
No,
or
no, 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 no. Phase one will be form, both will sender and the receiver will be exchanging the information, okay, exchange some
okay,
parameters and form the phase one. And in the
okay,
phase two also, it both the sender and the receiver will be exchanging some parameters and will form the phase two. The phase two will also have some parameters. I will tell you what are those parameters. So both will exchange, okay, both sender and the receiver will exchange, so that both will have same parameters in the phase two. So then they will form the phase two. Until unless phase 2 is from our actual traffic will not flow, okay.
okay. So we have any like commands for this one, or like once we created phase one and phase two, the traffic will pass from here to there, or we have to do something in the Palo Alto firewall.
Yeah, we have to do we have to build up the we need to configure first, okay, we need to configure phase 1 phase 2, and
Okay.
the phase 1 phase 2 has to be come up. I will show
Hmm.
you the in the lab how the phase 1 phase 2 will come up, okay. So
Okay.
until unless phase 1 phase 2 will come up, the our traffic won't pass, okay. The phase 1
Okay.
phase 2 tunnel should be on or should be up and running, then only our the traffic will be flow.
Okay. And also, I have very big doubt here.
Yeah.
So, if we have like, if we got some Palo Alto device,
Mm-hmm.
it is the new one.
Mm-hmm.
If we want to do like IPsec tunnel, what will be the steps we have to do decryption, everything, or how it would be new Palo Alto device?
If you have a new Palo Alto, okay, this is mostly the configuration will mostly depends upon the client requirement only. Okay, if the client wants to see all the whatever the things that are exchanging between one side to other side, they if they want to decrypt, okay, they will configure a decryption, and this
Okay.
bit mostly IPsec will be used for between side to sides only, okay. And
Okay.
if they want to send and their data in a secure manner, we need to go with an IPsec.
Okay, so what will be the steps if you got the new Palo Alto device and
Hmm.
if we want to do IPsec means what will be the steps?
What will be the steps? Okay, I will let you know in the whenever we are doing the lab, okay.
Okay, 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 got it. Thank you.
Yeah.
Yes, Karthik, just a small clarification.
Yes, go ahead.
Means just now you said that the phase two will use the things which are already done by phase one, right?
Sorry, sorry.
Here we have phase one and phase two. You said that the reason why phase two has less number of things which are you said, right? It is quick mode.
Yeah, we have only the phase 2 will have only the quick mode,
One
only
quick
one
mode.
mode.
Yes, that means you may, as you said, the other things which are there, like before that you have told in the phase one there are multiple things are available, right?
Yes.
Identification, authentication, everything,
Mm,
encryption.
mm.
So the the phase two will use the phase one to communicate, right?
Yeah, phase 2 will use phase 1 as a secure channel, but here also some parameters will be exchanged between sender and the receiver. I will let you know what are the parameters. See, in the phase 1 we are using some parameter to exchange, right? In the same way, in the phase 2 also we have some parameters that need to be exchanged between sender and the receiver, okay? but it won't use same parameters. It the phase 2 will have phase 1 will have separate parameters and phase 2 will have separate parameters.
Means
But
along with the phase two, like whatever the modes are there, including phase one, both of them will be used in the phase two, right?
yes, yes.
Okay, got it.
Yeah. See here in the phase 2 also I said these three messages are encrypted, but inside if you want to bring up the phase 2, there are certain parameters also needs to be exchanged, which is called protocol. Okay, here we have two protocols in the IPsec, which is an ESP and AH. ESP is an encapsulation security payload, and AH means authentication header. And in the same way we have authentication. Okay, we have same group, lifetime, and encryption. Okay, so these are also the parameters that are going to exchange between sender and the receiver in the phase 2. The first thing is an protocol, and in the phase 1 I told you it is an haggle parameters, right? In the phase 2 I'm just remembering with the name called paggle. Okay, which is an PAGLE. P means protocol, A means authentication, G means group, and L means lifetime, and E means encryption. Okay, don't confuse with whatever the parameters we are using here. Should no need to use the same parameters here. You can go with an different parameters. Okay, but the protocols that we are using here is an two protocols that will support in the IPsec. One is an ESP and AH. What is difference what is the purpose of ESP and what is the purpose of AH, and what is main difference between ESP and AH? Okay, so we are calling ESP and AH as a protocols, right? If you are calling as a protocols, each protocol will have its own protocol number. So ESP is having an protocol number 50. Okay, and AH is protocol number 51. Okay, ESP is an encapsulation security payload where it will be supporting authentication. Okay, integrity, and encryption. Okay, it will be supporting an encryption, and AH it will only supports authenticate. We are calling as an authentication header, right? So it will be supporting only authentication and integrity. Okay, here these protocols will be used mainly to forward our actual data. Okay, once the phase 1 and phase 2 will form, let's see, we have the system here and we have a server here. If I want to access the server from this PC, so it has to be flow through the tunnel, right? So the phase 1 will be formed and phase 2 will be formed. Okay, and I'm trying to ping the server. Okay, I'm trying to ping server, or I'm trying to access any of the applications that are available in the server. Okay, so we are generating a traffic, right? So this actual traffic will be used you inside the phase 1 and phase 2. The actual traffic will use these protocols. Okay, our actual traffic will be flown using this ESP protocol. Okay, if you are using a ping, our ping traffic will be in the ESP or AH. Okay, in the packet capture, if you take a capture of the packet, what you will see is, first you will see an phase 1. Okay, phase 1 if you are using main mode or if you are using aggressive mode. Okay, in the phase 1, if you are using main mode or aggressive mode, it will be having those messages, and after that we will be having phase 2, which is an quick mode, and after that we will be having ESP as a payload. Okay, ESP as a payload where our actual traffic will be carried, ESP or AH, whatever it may be. If you are using ESP, our actual traffic will be use ESP as a payload. If you are using AH, our actual traffic will use AH as a payload. Okay, this ESP and AH will only for our actual data. Okay, carrying an actual data which is flown inside our phase 2. Okay, phase 2 tunnel. And these are the two important protocols, but here by the whenever you are forming IPsec tunnel between site to site, it will be going with an ESP protocol because of this encryption. Okay, here it will be going with an ESP. If you want to configure AH also, you can configure, but whatever the data or whatever actual data we have an production phase 1 and phase 2. Even though the phase 1 and phase 2 is compromised, we'll be having a payload, right? This payload will be having an encryption, or if you use an ESP, but if we are using AH, we don't have an encryption, we have only authentication and integrity. Okay, for our actual payload. Okay, these are the two protocols that we are using, and these are the parameters all that are exchanging between sender and the receiver in the phase 2. Okay, in the quick mode. And we have IPsec modes. Don't confuse with our phase 1 phase 2 modes. Those are the IKE modes, and which helpful for to build the IPsec tunnel. But there are two IPsec modes. One is an transport mode, and tunnel mode. Okay, why we are using transport mode and why we are using tunnel mode means, see here, whenever you are sending some information, some data from one side to other side, how the packets will be seen in the packet capture. We will be having first L1 header, will be having L2 header, will be having L3 and L4. After that we'll be having our payload, right? Our actual data. Okay, our actual data will be there as a payload. Okay, in the transport mode, whenever you are using a transport mode in the IPsec, and we have received this data. Okay, we have received this data from our Windows machine, and whenever you are using transport mode, what it will do is it will be sending to the sender as it is. It won't modify anything here. It will be sending L1, L2, L3, L4, and it will be having this actual data here. It will sending as it is. In the transport mode, it will be sending as it is without modifying anything. But whenever you are using a tunnel mode, okay, how the packet will be look like is, whenever you are using this traffic, we have L3, L4 and actual data. So in the tunnel mode, what it will do is, once this data will received from the our local machine or from our Windows machine, what IPsec tunnel will do is, if you are using tunnel mode, what it will include is, before this L3, it will be adding a new L3 header. Okay, how it will look like means, we'll be having L1, we'll having L2. After L2 we'll be having new L3 header, and after that we'll be having L3, L4 and data. Okay, why we are why it is adding new L3 header whenever you are using tunnel mode means, in order to secure our actual data. Okay, in order to secure our actual data, a new L3 header will be used. What it contains, new L3 header means, whatever the IP address that we have on the IPsec interface. Okay, we are using one IPsec interface, right? It will include this IP information in the new L3 header. Mostly this IP information will be of public IP address. Okay, so this L3 header means our actual traffic. Okay, this L3 header, our actual traffic, this is a source IP, this is destination IP. These are some private IP address, right? So in order to protect our private information, what we the tunnel mode will do is, the tunnel mode will be adding a new L3 header which will be having the information of public IPs. Okay, whatever the interfaces that are using to build the IPsec tunnel, the IPsec tunnel will be include that IP information in the L3 header, so that our actual L3 and our actual original L3 packet will be encrypted or will be under the new L3 header. So whenever the whenever the hackers or whenever the users that are sitting in red, they try to access, they will only be getting this new L3 header which will be having some public IP addresses. With a public IP address they can't do anything, so our actual private data will be safe and secure with this new L3 header. Okay, so mostly the transport mode will be used between our end devices. Okay, whenever you are sharing communication between end devices, the transport mode will be used. But between the site to site, between the firewalls, we can use an tunnel mode. Okay, here we can use an tunnel mode, and whenever you are sharing information between directly between systems, we can go with the transport mode. Okay, these are the two modes in the IPsec. Okay, and do you have any queries or any questions on this? Any queries or any questions? Actually, this is our last session in this IPsec modes. Do you have any queries regarding the protocol or regarding the IPsec or regarding anything in this IPsec?
No, Karthik.
Yeah, good. Others?
No, I'm good.
Okay, perfect. Okay, and we have one small topic called natty. Okay, I will explain this. This is not a part of this, but this is one thing that you need to know. We have natty in the IPsec. Okay, why we use natty? We can natty means NAT traversal. Okay, NAT traversal. Why we use NAT traversal and what is the purpose of natty in the IPsec? Okay, for suppose if you have devices, or if you want to form IPsec between one side to another side, before we are seeing that we don't have any we have a devices, but we don't have any NAT device in between. So for suppose if you have any NAT device in between our IPsec feeds. Okay, whatever the traffic that is flowing from one side to another side, it is flowing through the NAT device. We that is flowing through the device which we have, where we have configured a NAT. Okay, this is a NAT device where we have configured a NAT. Okay, so whenever there is a NAT device, there is an situation where IPsec will not compatible with the NAT, because IPsec is an L3 protocol, right? Yeah, IPsec is mostly using for the L3. Okay, but NAT will work on L4. Okay, NAT will be working on L4. So because IPsec, yeah, we are using an ESP packet. Okay, ESP protocols will always be in the L3 only, right? So we are using an L3, right? So this L3 will not compatible with the L4. So in order to process our L3 traffic through the L4 device, we have to enable the NAT traversal in the IPsec feeds. Okay, here you need to enable NAT traversal. Here also you can enable the NAT traversal, so that whatever the our L3 traffic will be flowing, what it will do is, whenever you have enabled the NAT, it will be encapsulated in the L4. It will generate a new L4 packet, and it will be encapsulated in this L4 packet. Okay, it will be generating an whenever you have enabled the natty and the IPsec feeds, it will be generating an new L4 packet with the, I told you, right, here the port, whatever the port that are using in the IPsec, it is an UDP 500, but it will be generating a new L4 packet with the port. If you are enable the natty, it will use the port UDP 4500. Okay, it will generate an UDP 4500 L3 packet. Whenever this packet reaches the natty device, it will decapsulate this L4 packet, and it will be forwarding this our ESP packet through the device. Okay, if there is no natty, we don't have a L4. Okay, directly it will sending an ESP packet. ESP packet is an L3 packet where natty won't pass this ESP packet. Okay, this is a one small topic in the IPsec, why we use natty and how we can use. Okay,
So,
you got the point,
natty.
right? Or do you have any confusion or questions on this?
So, I have a question. Natty and nat rules both are same or it different?
Both are same. Whenever you have NAT, okay, whenever you have NAT device in between, we have configured NAT rule here. Okay, on this device we are configuring NAT, but we are enabling the NAT on this IPsec piece. We are not configuring NAT rules here. We are just enabling the NAT here. So whenever this traffic is passing through the NAT device, this NAT rules will be applicable here only, not on these devices.
Okay, in Palo Alto devices, it will be default. I mean, like by default, it will be enabled, or we
No,
need
no,
to
no. We
enable
need
it.
to enable. It is depends upon whether there is a NAT device or not. Okay. If there is a NAT device in between our IPsec pits, we need to enable the NAT, or otherwise you no need to enable NAT. Okay.
Okay.
Yeah. I have already prepared an detailed document on this NAT. Okay. You have an access to our website, right? You have a password for the website, or you don't have.
No, no.
Okay, I will let you know the password of our website. So we have every document that are placed in our website, so that you can go ahead and download and you can use that for the reference. Okay, I have made an detailed document for NAT and placed in that. See here, this is our NAT transversal, and this is a detailed document. Okay, how the NAT works and what are the things whenever NAT device is there, what how the NAT traversal will work, how the NAT device will recognize. Okay, just go ahead and I will share the password. Okay, after this meeting I will share the password. Go ahead and download this NAT traversal. Okay, and you can able to understand, and this troubleshooting scenarios I will discuss in the whenever you are doing lab. Okay.
Okay, that sounds good.
Yeah.
Thank you so much.
Yeah. Any questions, any further questions before that's all about the IPsec. Okay, and if you have any questions just let me know, otherwise we can wind up this session here, and after that, after the class also, if you have any questions just let me know. Yeah. Okay, guys. If you don't have any questions, we can wind up this session here. Thanks for joining. We can do an IPsec lab tomorrow at the same time. Just join at 5:30 tomorrow. Okay.